In this video, let us solve problems based on the law of cosines. Alright, so here we have the questions. In a triangle ABC, if A equals 3, B equals 5 and C equals 7, find cosine of A, cosine of B and cosine of C. Alright, so what we have is we have A equals 3, B equals 5 and we have C equals 7. And we know that cosine of A equals B square plus C square minus A square divided by 2BC. So all that you have to do is just substitute the values of A, B and C, and then you find the cosine of A, cosine of B and cosine of C. So here B square is what? 25, 5 square is 25, plus C square is 49, A is 3, so it's minus 9 divided by 2BC, 2 times B is 5, 10, 10 times 7 is 70. So what do you have? You have 65 by 70, and 5 goes 13 times in 65 and 14 times in 70. Alright, so that's cos A. Next is cos B. Cos B is nothing but C square plus A square minus B square divided by 2CA. And now substituting the values, C square is 49, that is 7 square is 49. Plus A square is 9 minus B square is 25 divided by 2CA. 2 times C is 14. 14 times 3 is 42. So you have 49 plus 9 is 58. 58 minus 25 equals 33. So 33 divided by 42. Alright, so you have 3 goes 11 times in 33 and 14 times in 42. So cos A equals 13 by 14 and cos B equals 11 by 14. And finally we have cosine of C. So cosine of C is nothing but A square plus B square minus C square divided by 2AB, which is equal to A square is 9 plus B square is 25, 7 square is 49 divided by 2AB, which is 2 3s are 6, 6 5s are 30. So 25 plus 9 is 34, 34 minus 49 is minus 15 divided by 30, which is equal to minus 1 by 2. So hence we found cos A, cos B and cos C by the help of the law of cosines. Alright, so let's quickly solve another problem before we end this video. Alright, so here we've got a problem. It says in any triangle ABC, prove that A of B cos C minus C cos B equals B square minus C square. Alright, so what we have in the LHS is A of B cos C minus C cos B. Alright, so just multiplying, we have AB cos C minus AC cos B, alright, which is equal to, write AB as it is, but cos C, we've got a formula, right? Yeah, alright. So we've got AB and then do not write cos C as cos C itself. Cos C should be written as A square plus B square minus C square divided by 2AB. This follows from the law of cosines, minus AC of cos B again. So cos B from the law of cosines, we have cos B as A square plus C square minus B square divided by 2AC. So now that we've substituted the values of for cos C and cos B by these, we can see that we can cancel AB and AB and AC and AC. So all that we are left is with A square plus B square minus C square divided by 2 minus A square plus C square minus B square divided by 2. So in both the terms, half is same. So take out half and all you've got is A square plus B square minus C square. Minus of A square is minus A square. Minus of C square is minus C square. Minus of minus B square is plus B square, right? So you've got A square getting cancelled and then you have B square plus B square, which is 2B square, and C square and C square minus 2C square. Again, since the two are same, take out 2. So it becomes 2 by 2 of B square minus C square. 2 and 2 gets cancelled. And what we've got is B square minus C square, which is RHS. So we started off with the LHS and we did prove that A of B cos C minus C cos B equals B square minus C square. Alright, so that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on the law of cosines.